All right, this question is a super common question on the AP test. I basically give you two situations and two different students, and they kind of argue, and you're basically supposed to figure out who's correct and who's incorrect. So let's go through them one by one and identify both. So student A, so you in the first situation you have basically there's two masses on a ramp. In one case you have a velocity going up the ramp. In the other case you have a velocity going down the ramp initially. Okay, so let's go through student A. So student A says both cases have the same mass and same angle. So that's a good statement. I'm going to highlight this in yellow if it's true. And therefore, both cases have the same gravitational force. So that's also a true statement. Both cases have the same frictional force. This is true, I guess, kind of. The same magnitude of friction. Now, the direction is going to be different. This one on the way up has a friction going down, and this one on the way down has friction going up. Remember, friction always opposes the direction of motion. If both cases have the same forces and same masses, they must have the same acceleration. So that's not a true statement. We'll go ahead and highlight that in red here in a second. And if the acceleration is the same, the final velocity are the same. This is also not a true statement. All right, let's look at student Y. You are not taking into account the direction. So that's kind of just what I said. They do have two different directions in case one. The friction and gravitational forces work together to create a greater force than in case two. This is a true statement. And so if you look at this has a force going down, right? Actually, let me change the color here so it's a little bit easier. So this one has a force coming down, right? Friction, opposing the direction. And then you have your mg sine theta also going down. So they're both in the same direction. So that's going to create an acceleration down this way. And then in case two, friction opposes the direction. So friction is going to be this way. And then your mg sine theta is going to be this way. So the net force and therefore the net acceleration should be less in case number two. Okay, so let's go back, and therefore greater net force means a greater acceleration. Okay, that is true. And since acceleration is greater, the final velocity will be greater. This is a false statement. So let's go ahead and do all our false statements here. This is just because the acceleration is greater in case one, the final velocity is not necessarily going to be greater. And I'll talk about that in a second. Let's go mark the wrong ones here. Both have the same forces, same masses. They must have the same acceleration. This is a false statement. And as we just described earlier, and therefore the velocities will be the same. Okay, also a false statement. All right, so let's go back to this this statement here. The final velocities will be greater in case one. So notice here, this one, you have this velocity, it's coming down and it's going to accelerate. It's going up and then coming down, right? So on the way up, it does have a greater acceleration, but it's slowing the mass down. So it's going to get slower and slower and slower. And then on the way down, it's going to start to speed up this way, right? Now, when it passes this original point, because it's slowed down on the way up, when it passes this original point, its velocity, let's say this velocity is 5, and let's say this is 5 going up. So when it passes back down, because of friction slowing it down on the way up, when it passes down this point, it's not going to be 5. It's going to be less. Let's say it's 4, for example. And so because it's going less in that situation, what that means is, well, the final velocity at the bottom will also be less. Now, this question I'm giving you in the context of forces, inclines, etc. You could also use this with energy. And so even though it's not an energy unit, you could use it to describe using energy as well. So for example, there's more work being done by friction, both on the way up and on the way down. And so since there's more energy lost to friction, that means the final velocity at the bottom should be less, because there'll be less overall kinetic energy down there at the bottom. All right, so here's kind of a summary of what I just said. Why don't you take a minute just to read through this? So yeah, actually go ahead and pause the video here and read this over, make sure you understand, and then I want to go ahead and focus on a few things. So again, pause the video and then come back. All right, so we're back. So here's correct statement for x, incorrect for x, correct for y. Let's go ahead and talk about the incorrect for y just a little bit. So one thing I didn't mention earlier is that the acceleration actually changes. So it's not exactly constant, right? On the way up, as we mentioned before, there's an acceleration downwards, right? Slowing it down on the way up. But then on the way down, the friction is going to oppose it, and so there's acceleration down still because gravity is more than friction, but that acceleration is going to be less. In fact, on the way down, the acceleration for case 1 and for case 2 are both going to be exactly the same. It's just on the way up, case 1 has more acceleration, slowing it down at a greater amount. Okay, so this kind of last statement, I kind of described why the final velocity is not greater in case 1. Again, you could also use energy to explain this. So the very last thing I'm asking you to do on this assignment is to go ahead and kind of summarize everything, put it all together. Like if they asked you, you say which one is going to be have a greater acceleration, which one is going to be faster, write kind of a paragraph statement. So if you haven't done that yet, or if you have, maybe you want to go ahead and go back and modify that, go ahead and do that. I would just kind of, at this point, you just kind of take together all the correct statements that you have from both people and just kind of use that to construct your paragraph. And I would kind of use this idea in general as you're writing these paragraphs just to come up with all the main ideas. All right, so let me know if you have any questions.